Hey, Algebra 2. Well, we're moving on to one of my absolute favorite lessons. We are in 6-7 and we are talking about imaginary numbers. And you will see this as a little cursive I, just like you see right here. Our essential question is, can you use the number I to simplify square roots of negative numbers? The very first thing that we need to know is I is equal to the square root of -1. And I squared is equal to -1. Therefore, that little triangle is a therefore, the square root of -r is equal to I root r. All right, so what does that mean? That means this. The square root of -32, we still have to break up 32 the way we know how, 16 times 2. Where the 4 can come out and the root 2 stays in. But because of this negative, where we know with real numbers that can never happen, we have to state that this is an imaginary number. So we're going to write 4i root 2. So if we have this, we always, I always say something funny and people seem to remember it. So always pull out your eyes. Pull out your eyes first. Okay, so sometimes people think of these as eyeballs and they laugh because they think, pull out your eyes, that's so funny. So we want to always pull out our eyes first. So I know I can take an I out of root -6. And I know that the square root of 24 can break down to be 4 and 6, where because it is 4, this will be 2i root 6. And here, I do have like terms. 5i root 6 minus 2i root 6 is 3i root 6. When you're multiplying, this is the most important time to pull out your i's first because you want to show those i's in that we're multiplying I times I. So this will be I root 3. And we know 27 can break down to 9 and 3. And this would be 3i root 3. And now we're just multiplying. I times 3i is 3i squared. And root 3 times root 3 is root 9. So we got a lot more to break down here. I know that I squared is equal to -1 because it told me in the directions above. And I know the square root of 9 is 3. So the answer to all this craziness is -9. So remember, if you did not pull out your i's first, you would have gotten a +9 because you would have multiplied the negative times the negative. So make sure you pull out your i's first. Now, I want to continue to talk about this I squared right here. Sorry, I think I just erased that I squared. We do have a little pattern in the midst of our imaginary numbers. So we need to know that I is going to equal I. I squared, we learned, is equal to -1. I cubed is equal to -I. And I to the 4th is equal to 1. All i's go in series of 4. So if I was to get a question of I to the 37th, what I'm going to do is I'm going to notice that I to the 1st is I to the 2nd is -1, and then it's going to start repeating because I to the 5th, remember, is I times I to the 4th, and we just said that I to the 4th was 1. So notice if I look at I to the 5th, I can split it up in terms of 4. I could put everything in terms of 4. And I have to notice that the remainder, or I could say, hey, 4 goes into 5 with a remainder of 1, and that's where we go. So I'd say, hey, I'm going to go here. Well, if I took 4 into 37, that does go 9 times, and I get 36. Notice I also have a remainder of 1. So I to the 37th power is equal to I, because I'm going to go to the first one. Now, obviously, it's going to get a little different. What if I have I to the 47th? We know this is going to be a little different. We could take 4 and divide it into 47, which goes 11 times, right? And that's 44 with a remainder of 3. So for this one, I'm going to go negative I, because I have to go to the third one, I to the third. So this thing that I gave you right here in red, these are really, really, really important to memorize, to look over before taking an SAT or an ACT, because those 4 are always circulating. So I see questions like this a lot. All right, I also see questions like this. So we already did one like this. Let's do another. We know to pull out our i's first. So if I have root negative 5, I'm going to have I root 5. I know 75 is 25 times 3. So 25 is 5. Don't forget your I because of that negative. Root 3. And when I multiply these together, I times 5i is 5i squared. Oh, we can keep going. And root 5 and root 3 is root 15. With my final answer, because I squared is equal to negative 1, it would be negative 5 root 15. All right, 2 more questions here. You can barely see this one. If I have 4 root negative 18 over the square root of negative 12, we can break this one up the same way we did everything else. I'm going to take that I out. I know 18 has 9 times 2. With the negative 12, I know this, I'm going to take an I out. And this is 4 and 3. So let's rewrite this. 2, 3. So on the top, I end up getting 12i root 2. On the bottom, it looks like I have 2i root 3. Let's continue to reduce just like we would. The i's actually cancel out here. And we have 6 root 2 over root 3. But what has to happen with that radical 3? We do have to go ahead and rationalize the denominator. So when I rationalize the denominator, oops, I need to put my pen on again. I have to multiply by root 3 over root 3. So I get 6 root 6 over, well, root 3 times root 3 is root 9, which is 3. And our last bit of reducing is just going to give us a 2 root 6. Now, the reason why we learn imaginary numbers is to get to this right here. We are solving. So notice this is a quadratic. 4x squared plus 25 equals negative 23. In your gut of guts, you would know to subtract 25 to each side. 4x squared is equal to negative, looks like it's 48. And when I divide each side by 4, x squared is equal to negative 12. Now to get rid of that x squared, I do have to take the square root. And when I take the square root of each side, x is equal to plus or minus, don't forget that plus or minus, the square root of negative 12. But negative 12 can break down to be 4, well, we could take that I out, and 3. So it looks like x is equal to plus or minus 2i root 3. And we're doing all of this to get to solving with imaginary numbers.